Here we have a table of various exhaust camshaft and intake camshaft positions with various RPMs and various throttle positions. But what do these camshaft position numbers actually mean, and how do they relate to the waveforms that you plan to look at? Here you can see a chart that we used. It came from the factory service manual for this vehicle, but it's not adequate to explain this situation. In this chart, the bottom left arrow is the firing line number 1, and the top center arrow is 360 degrees later after that firing line number 1, when the cam overlap might occur. And then the third arrow on the bottom right is 360 degrees after the overlap may have occurred. So that's to get things started here. We know the exhaust cam degree angle of minus 123 degrees at idle, but what does that actually mean? The way they chose these timing numbers is that they used the firing line, which isn't on this wave chart. It's on the left side and on the right side of this chart. So they chose that as their reference point. So the exhaust camshaft is minus 123 degrees. The 123 degrees is after the previous firing line, but they gave it a minus sign because it's before the valve crossover point. It's hard to understand why they chose this methodology, but that's what they did. The intake cam, likewise, it's not referenced to the top dead center of the overlap time of the two valves. Instead, it's referenced to the next firing line. And it's a positive number because it's on the right side of the valve crossover point. With this new perspective, we can now look at this chart and understand that the exhaust cam opens a valve 123 degrees after the previous firing line, which makes it a minus 123 degree number. And likewise, the intake valve closes 148 degrees before the next firing line, and that makes it a plus because it's before the firing line. But here is the rub. The scan tool reports that as the RPM increases with the load, then the intake cam numbers decrease. The numbers get smaller, and that's a problem. I believe the scan tool is mistakenly using this closing point at idle as a reference to calculate the dynamic changes in the timing of this intake camshaft. And therefore, when they give you smaller numbers, that means this waveform is moving to the left, which is what it should do. It's advancing to the left. So I think there's a little problem here with the scan tools or with the computer reporting the data to the scan tools. Here on the waveforms, we can see the first firing line pointed by the left arrow and the exhaust cam opening time on the right arrow. And on the other end, we have the second firing line on the right arrow, and we have the intake closing time on the left arrow. These time units can be counted by counting the pulses. The pulses are 6 degrees each. If I have this all wrong, I'd like for someone to correct me because I can't see any other way of explaining these charts. So feedback would be appreciated even if you don't agree with me. So that's the end of this video.